Okay, so in this example, um, for volume, we're going to be applying the Washer method. I'll show you how I sort of visually see the Washer method in these examples. Let R be the region bounded by y equals 4 minus x squared and y equals 0. Find the volume of the solid by revolving R about y equals 7 and then y equals -3. So there's two different examples, and we're going to set up these integrals, but we're not going to evaluate them, only because the evaluation takes a longer process. Okay, so if I want to set up, if I want to do at least part A, I need to make my sketch. So first of all, look at your equation, y equals 4 minus x squared. What type of equation is that? It's a downwards parabola with a vertex of 0, 4. Right? So for part A, we begin with our sketch. Let's say here's my y-axis, and let's say here's my x-axis. So I'm drawing a parabola where the vertex goes somewhere around here, 0, 4, and I'm drawing the parabola. So let's say that our parabola looks something like this. We'll use dotted lines first, and then we'll try to like connect them. Okay, so we have our A to B, and now here we go. And we also know that it was bounded on the by the y-axis. Sorry, not the y-axis, the x-axis, because that's y equals 0. Damn, my parabola came out really awful. See if I could. I'll just leave it the way it is. It's okay. So that is your y equals 4 minus x squared. And we know that we're rotating about a line, which is no longer the x-axis. This time it's y equals 7. So if this was 0, 4, then let's say somewhere above here is y equals 7. All right. So first of all, we can find our limits of integration, our value of a and b. If you want to find the values of a and b, you can set the quadratic 4 minus x squared equal to 0 and solve for x. Right? So you could have done this more than one or two ways. You could have add x squared on both sides. So you could have said 4 is equal to x squared, right? Which is the same thing as saying x squared is equal to 4. And then you could take the square root of both sides. You'll get x equals plus or minus square root of 4, but the square root of 4 is just 2. So these values a and b are actually -2 and +2. All right. So we're, again, rotating about this line, y equals 7. So if I'm rotating about the line y equals 7, there's a couple of things that I need to do. First of all, I need to find the distance between the x-axis and y equals 7. Well, what do you think will be that distance between the x-axis and y equals 7? Not 11. Try again. You look at your x-axis, which is y equals 0, and look at the line of rotation, y equals 7. It's going to be 7, right? So we have this piece being covered. Okay, so this has a distance of 7. Okay, now another thing that we have to look at is the distance between your curve and your horizontal line, y equals 7. So that distance is not going to be 7. It's not going to be 3. Here's why it's not 3. That distance solely depends on, wait, let me change the color. This distance in the lighter shade, I should use a different shade. Make this blue, a light blue. One sec. If you look at this distance that I drew there, with the light blue, that's the distance between your function y equals 4 minus x squared and y equals 7. So to figure out that distance, you have to do 7 minus 4 minus x squared. So it looks like this. This distance in blue is 7 minus 4 minus x squared, which is just really 3 plus x squared, right? Because if you distribute the minus sign inside the parentheses there, 7 minus 4 is 3. Negative of negative x squared is positive x squared. Okay? Why did I do this? Well, I told you at the beginning that I'm applying a washer method. So remember, when you're applying some sort of, when you're dealing with some sort of rotation or revolving around some line, you're reflecting it about that line, essentially. If you want to do it on the 2D, on a 2D graph, on a Cartesian plane. So that purple line, the thicker, the longer line, I could reflect it over that line, y equals 7, and the smaller region, which is shown in light blue, can be reflected over as well. Essentially, this allows me to create a washer, right? A donut. Here's going to be my first donut. Sorry, here's the first disk, right? You're going to have basically like one disk inside another. Here's the first one. Not the best of graph. I screwed up the arcs there. It's okay. And here's the second one. And there you go. I'll zoom in. That's your washer, right? What I did was I looked at the distance between the two horizontal lines, y equals 7 and y equals 0. That distance is 7. Then I look at the distance between y equals 7 and y equals 4 minus x squared. That distance will be 7 minus 4 minus x squared, right? One function minus another. So 7, if you distribute the negative sign inside the parentheses, you would get 7 minus 4 plus x squared, which is just 3 plus x squared. Now, those distances, since we're doing a rotation about the line y equals 7, you can reflect it over y equals 7. So if I reflect those purple and light blue regions with dotted lines, that helps me create my washer or donut. Okay? Now, more importantly, these two pieces are important because these pieces essentially gives you two radius. You will have a big radius and a smaller radius. Which one of those two pieces that I just circled there or put a box around, which one is the bigger radius? 7. So 7, I'm going to label it as big R. And 3 plus x squared is little r. And now that my image is essentially completed here, I can now set up the volume. By the washer method, we say that volume is equal to pi from A to B of big R of x squared minus little r of x squared dx, right? Big radii minus small radii. The bigger radii is just going to be 7. The smaller radii is going to be the 3 plus x squared. The A to B is going to be the point of intersection of the region, which was drawn in red. That was the y equals 4 minus x squared and y equals 0. So you'll get pi from -2 to 2 of 7 squared minus 3 plus x squared. Sorry, yeah, 3 plus x squared dx. And that will be it for part A. Any questions before I do part B? I might have to use different colors. No, that's not gonna work. All right, guys, ready for part B? All right. So in part B, same thing again, but this time we use the line y equals -3. Here's my graph one more time. I'll try to make it where it's a little bit better to view. So here's 0, 1, oh, sorry. Say 1, 2, 3, 4. So I know that would be the vertex. -1, -2, 1, 2. So these were some intercepts for 4 minus x squared. Now I could draw the parabola. All right, there we go. Not the best of parabola. Kind of messed up the second arc there. That's fine. So we have y equals 4 minus x squared. The region was also bounded by the x-axis, which was y minus 0. Y equals 0. Okay, now we're going to rotate this region over y equals -3. So let's say -1, -2, -3. Okay, ready? So again, what did I say earlier? What we're going to look for is two things. One, what is the distance between the x-axis and your axis of rotation or revolving, which is y equals -3. And then we're going to look at the distance between y equals 4 minus x squared and y equals -3. That would help you with finding essentially your outer radius and your inner radius. So let's start. If I begin with the, let's just choose some point. Let's just say somewhere here. I choose this point in green. What is the distance between the x-axis and y equals -3? How did you get 3? Well, let's try to do it mathematically. How would you get -3? Oh, sorry, how would you get 3? You're right. You're absolutely right. That distance between this distance that I drew in green is definitely 3, but how can I show that mathematically? Not necessarily, but yeah, yes, but you'll need to apply an absolute value here. Bless you. Well, if you want to find a distance between two values, what do? Do you add? Do you subtract? No, I said if you want to find a distance, like for example, the distance from point A to point B, not even points, like the distance from that wall to this wall, what do? You won't add, but rather you subtract, right? You will take whatever this distance is from that point to that point, subtract. Okay, so here what we're going to be subtracting here actually is 0 minus -3. So what is 0 minus -3? It's just 3. So you see, that's how mathematically you get the 3. You're looking for the distance between y equals 0 to y equals -3. That distance is 3. Another way to think about it as well is if you start with y equals -3 and you want to go up to x equals the x-axis, you got to go up by 3 units. Okay, so that works. All right, let's try it again now. This time, we got to find the distance between 4 minus x squared and -3. So if I start with my green point again, that point there, then at that point, here's where you're going to be on the curve. but you're looking at this distance. Welcome to Lehman College. Things like this happen on a normal basis. Okay, so if you look at the this blue that blue line that I just drew, you can find the distance mathematically as well by taking 4 minus x squared minus 3, or minus -3. So if you work this out, what is 4 minus -3? Yeah, it comes positive, so it's 7 minus x squared. Very good. Now this is helpful because when I draw essentially my two radius, I will form my two discs. I ultimately form the washer, right? So if I reflect this blue piece over, we'll get something like this. And if I reflect the green piece over, our axis of revolution, we'll get this disk. So you can see that there is ultimately going to be a washer. So which one is the outer radius when you look at this graph? Would it have been 7 minus x squared or the 3? That's right. This will be your big R. This will be the little r. So our volume, V, is equal to pi times, volume equals pi times the integral of -2 to 2 of 7 minus x squared minus 3 squared dx. And that's it. All you had to do was set up the answer. And we're done.